So we are continuing with how the subject of quantum field theory developed. So in the previous class, what we did was we saw how the general structure of quantum field theory, the two viewpoints. एक particle viewpoint and other is a field theoretical viewpoint. How quantum field theory as such got evolved by these very two ideas. So in this today's lecture, so we'll have a sort of wave equation. So which is so from this, it's one of the important ingredients of how we study quantum field theory. So relativistic wave equation में हम basically the Dirac equation, how Dirac equation का evolution कैसे हुआ था. So it's very much important, the conceptual way how we arrived at Dirac equation. So this is our today's class will basically concentrate on that. So if you remember in the previous class, I also said that foundations of wave mechanics, which was given by de Broglie, Schrödinger, and the role of special relativity, the plus quantum mechanics was very much in how we try to formulate quantum field. And prior to that, हमारे पास the role of matrix mechanics, which was there. Matrix mechanics and wave mechanics में कैसा उसका interplay कैसा हुआ था. Before we can say how we can incorporate special relativity with quantum mechanics. That's the point. So in, for example, matrix mechanics, our instance was on we should have observations. We should have observables, energy levels, or emission and absorption rates. So first it was Schrödinger historically who arrived at a relativistic wave equation, because he was not satisfied with that. He was not satisfied with because it gave the previous equation gave जो fine structure of hydrogen constant है, fine structure of hydrogen, it gave a wrong value to the scene. In that sense, it was incorrect. So independently, Klein and Gordon basically they also arrived at Schrödinger's relativistic wave equation. Okay. So this is the sequence. So in the traditional sense, जो हमारे पास ये है, for example, the equation show form of that equation, it will have a form like this, which you might have studied in your earlier classes. So if I just previously the propagation can also be written like this, and nu is written by this. These were the important ingredients once we went from wave mechanics, जैसे de Broglie's probability wave, the identification of variables was like this: propagation momentum and this is equal to h. They are the part of this. So you might have also gone through this thing. So if one form of this equation can be written like this: P plus EA by C square minus M square C4. So this is a sort of you can have a potential for like this A. Yeah, this is energy. So for a free particle described by plane wave. So it will be like this, exponential of k dot x minus mu. So de Broglie wave की जो identification होगी p की, it will be like this, h of k, or we can write it like this. If you see in terms of quantum mechanics, how momentum variable can also be like this. In the same way, we can write. In the same way, we can write function variable can be written like this is a momentum. Another equal in quantum mechanics. In terms of operator form, we also write it like this. If you remember, we'll write it like this. Now, the point is like what Schrödinger guessed. Schrödinger ने क्या किया? That an electron in an external field with potentials A and phi would be described by wave function psi of x. We have the evolution of wave in terms of space and time. Is obtained by making some replacements. Replacements means इसका momentum का this form, energy का this form in this equation. So equation will take this form. Minus c square minus iota. Okay, you can write it 4, you can write it. In particular, for since initially जो Schrödinger का था काम for hydrogen atom के लिए, तो hydrogen atom में वो it did not give this fine spectrum fine structure constant का spectrum did not come out right. So if we assume it like this way, for example, for stationary states, कौन होते हैं? Stable states or states which are normal shell electrons within, you can take them as stationary states. And for stationary states of hydrogen atom, so जो A है potential है, it will come out to be 0, and phi will be potential energy. It's 2 by 4 pi epsilon naught r. तो Q के बदले E है, charge इलेक्ट्रॉन. It will be E by 4 pi r. And if psi has time independence, then it will be exponential of minus iota E by h. Okay. Normally यहाँ पर जो E है, it's E2 minus E1. Right? 2 between two shells का. That's why we take it as delta E. So since it's stationary states, you can take it like this. So if it is that way, then so now we are going to substitute this here. इसको हम यहाँ substitute करेंगे. Okay. Here fine. So the equation will take this form. Iota h d by dt के बदले we are going to write E. So E plus E square by 4 pi r square इसके बदले this. ये E and E will be twice, that will be E square minus c square h square del square minus m square c4 psi of x. This is equation 5. So for your case, we are going to see how relativistic wave equation इसका एक conceptual evolution कैसे. Before we are arriving at Dirac equation, because Dirac equation becomes one of the foundations how we are going to study quantum field. ठीक है, इसका कंसेप्चुअल एवोल्यूशन क्या है. अब इन द सेम वे जो हमारे पास एनर्जी है, एनर्जी satisfying reasonable boundary condition, energy of these can be written like this. अब ये है क्वेश्चन. Solutions satisfying reasonable boundary conditions. Solutions satisfying reasonable boundary conditions will be where alpha जो है it's e square by 4 pi x. So these are solutions satisfying reasonable bound. अब ये क्वेश्चन है कि ये मैंने कहाँ से लाया. So if you go to a book of shift ये आप जाना as a reference to see how we arrive at this relation. Okay, we don't have time, otherwise we can just discuss this. Energy of general states क्या है जो ये है. तो ये alpha का वैल्यू ये है. Where n can be या अल्फा इज इक्वल टू, हमने अल्फा इज इक्वल टू दिस के बराबर है, इसी को हम कहते हैं फाइन स्ट्रक्चर कांस्टेंट. इसका वैल्यू क्या आता है नॉर्मल, इट्स 1/130. If n is a positive definite integer, then इसका वैल्यू आएगा between l and -1. But it was seen that alpha square was in good agreement with the experiment. जो आप earlier classes में पढ़ते हैं, Lyman series, Bolmer series, है ना, Parsons series, है ना. So once we did these very जो हमारे पास equations थे, we substituted here. So for this series, it agreed good with the experimental results. Okay. But once we substituted ये alpha का value यहाँ पर used for higher order values. Got the point? For higher order values, when alpha goes to 4, we substitute this इसका value for higher order values. So it gave solutions structure which was in disagreement to existing accurate measurements. ठीक है. Now you can also compare this equation with equation if you Arnold ने भी or Sommerfeld ने भी he had his own formula by some other methods. So for historical reasons, I say in old quantum theory, from certain quantization conditions, we can arrive at this formulas of formula. So by accident somehow this was explaining this जो हमारे पास discrepancy in the experimental results, but it had its own problems conceptually also. So इस सब का मेरे कहने का why I am doing the same thing. What Schrodinger's argument was basically that जो हमारे पास ये discrepancy यहाँ आ रही है when we are going to substitute for second order corrections, the discrepancy was that we are not accounting the spin of electron. Spin component है ना electron. So when the electron ऐसे persist कर रहा है और it goes from एक shell से दूसरी shell या transition हो रहा है from two moves delta E by T, ठीक है, स्टेशनरी स्टेट्स में। तो जो एडिशनल लाइंस जो आ रही हैं, स्पेक्ट्रल लाइंस जो आ रही हैं, तो उनका एक्सप्लेनेशन नहीं आ रहा था, ठीक है, इन फ्रॉम द फॉर when you compute the energy values, there came some discrepancy और कुछ, या जो स्पेक्ट्रम पे हमारे पास लाइंस आ रही थी एक्स्ट्रा, सो ही पोस्टुलेटेड इट मे बी कि इलेक्ट्रॉन का अपना एक स्पिन होता है, उस स्पिन की वजह से वी गेट दिस एक्स्ट्रा डिस्क्रिपेंसीज आउट देयर, and which was later, which you might have studied, observed by Goldsmith and Ullback, जिसको हम लेटर ज़ीमान इफेक्ट भी कहते हैं ना, spectral splitting of electron. If you take electron as in terms as tiny magnet, and once it's spinning around its own self, उस spinning magnet की, apart from this thing, it's revolving. When it's placed in a magnetic field, we'll have these splitting of spectral lines. तो उसकी वजह से ये जो discrepancy आ रही थी in terms of original energy, in that sense. अब ये है कि this means that elements of spin have to be coupled to orbital angular momentum, ठीक है, so that relativistic Schrödinger equation, यहाँ पे emphasis है, so that relativistic Schrödinger equation तो पहले भी थी, है ना, but it was not, we had not invoked special relativity, so relativistic wave equation will start with relativistic, so we have to the relativistic Schrödinger equation में orbital spin angular momentum को भी लेना है, then we can correct the fine structure splitting, correct the fine structure splitting. अब now comes Dirac into picture. यहाँ तक ठीक है ना? Schrödinger तक आप पहुँचे. Relativistic wave equation Schrödinger की did not agree with when we take higher order corrections. And Schrödinger ने सिर्फ hypothesize किया था spin may be that we are not accounting spin in this relativistic wave equation. ठीक है? यहाँ तक ठीक. अब इसे नॉट ओनली Schrödinger 1927 से आते आते बहुत सारे लोगों ने कहा था जो स्पिन ऑर्बिटल कपल, एक तो होता है थॉमसन्स प्रिसिशन, है ना, ऐसे ऐसे स्पाइरल, दूसरा है स्पिन, दो, एक थॉमसन्स स्पाइरल, ये है थॉमसन्स प्रिसिशन है ये, और दूसरा स्पिन है जिसको हम लिखते हैं J+L, है ना, फैक्टर्स L+, जो और कपलिंग जो है, सो व्हाटएवर, हाँ, टू इफेक्ट्स, दैट मींस एक डायरेक्ट कपलिंग है, मतलब एक डायरेक्ट कपलिंग बिटवीन मैग्नेटिक मूवमेंट एंड मैग्नेटिक फील्ड felt by electron as it moves through an electrostatic field. ये तो एक हो गया. दूसरा है relativistic Thomson's precision of spin and electron. जो आप if you have seen J is L+half and K is L+1 or J+half. एंड जो हमारे पास ये है E energy was not found to separately depend on N and J, but not on separately on L. These, so you can say energy was found to depend on energy but not separately on L. खाली L नहीं, L पर नहीं. and can take different values, spin half up, spin half lower, ठीक है? So you have the combined effect of this coupling and this coupling should account for जो हमारे पास extra जो आ रहा है. So this was the thing in that sense. अब now comes the picture. Dirac अब आ रहा है हमारे पास, ठीक है? So Dirac theory जो electron की है, it comes that he gave us a theory of this spin of electron from some fundamental assumptions. उसने कहा नेचर की कोई fundamental property है, उसको हम spin कहते हैं, ठीक है? उसकी वजह से which we have not account, so how we can account for that everything? So he Dirac ने famously पूछा एक question, what I should say. So because we do not still have a relativistic theory, we should account spin from the starting points, ऐसे point. Starting से ही हम spin को नहीं लेते थे. तो Dirac ने पूछा एक सवाल, Dirac, what is the famous question Dirac asked was, why do fundamental constituents of matter have spin ऐसे. अब इसमें डिराक के पास बेसिकली ये आ रहा था कि फ्रॉम दिस वेव इक्वेशन उसने कहा कि जस्ट स्टडी दिस इक्वेशन रिलेटिविस्टिक वेव इक्वेशन, श्रोडिंजर्स रिलेटिविस्टिक वेव इक्वेशन, इट्स आल्सो लेटर कॉल्ड क्लीन-गॉर्डन इक्वेशन, ठीक है? तो यू माइट हैव आल्सो स्टडीड कि जो प्रोबेबिलिटी आ रही है it should be positive, ठीक है? The answer he gave that we have to reinterpret the relativistic Schrodinger equation in a way which will take only the positive probability into account. We should only take the notion of negative probability was not there. So आप ये पॉजिटिव प्रोबेबिलिटी तभी कर सकते हैं क्योंकि जो इक्वेशन है इट्स ए सेकंड ऑर्डर डिफरेंशियल इक्वेशन, ठीक है? तो सेकंड ऑर्डर डिफरेंशियल जैसा है ना, न्यूटन्स F इज इक्वल टू m d2x by ये है ना d by dt ऑफ, अगर x होगा माइनस भी x होगा, अगर सेकंड ऑर्डर डेरिवेटिव टाइम है इट विल नॉट हैव एनीथिंग टू डू, अगर यूनिवर्स न्यूटनियन मैकेनिक्स में फॉरवर्ड डायरेक्शन एंड बैकवर्ड डायरेक्शन में हमको वी कैन नॉट डिस्टिंग्विश बिकॉज ऑफ सेकंड ऑर्डर डेरिवेटिव, ठीक है? द इवोल्यूशन इन टाइम माइनस स्क्वायर माइनस वन का स्क्वायर वापस आएगा प्लस वन. So in the same way, what Dirac said that the idea of negative probability which seems not to be the idea was this, the idea of negative probability seems to be fallacious. To get the idea of positive probability, will just change the original structure of differential equation into first order differential equation, second order partial differential into first. So that will correct the things for us and that will make ये हमारी पूरी interpretation हमारे लिए ठीक. This was the procedure. अब we have for this before the idea was this, before coming to that very idea for such that the probability density should be positive. So we know that जो हमारा wave equation है, if you have taken course in quantum mechanics, इसका जो equation है ऐसा, equation of continuity जो है, such that जो space integral है psi square. If you go to any book on quantum mechanics, the book is what Merz-Becker detailed. How can you interpret equation of continuity and Schrodinger equation का relation क्या है? The form is like this. Equation continuity क्या है? कोई भी closed sense में charge जो होगा ना, that will be constant. जितना अंदर आएगा उतना बाहर जाएगा, है ना? अब यहाँ charge नहीं, यहाँ wave function का evolution है in a closed space, ठीक है? उसका evolution on left hand side is this, right hand side it comes out to be this. Such that जो space integral होगा psi square is time independent. Is time independent. Such that ये ना इक्वेशन ऑफ कंटिन्यूटी इज लाइक दिस, है ना? अब इक्वेशन ऑफ कंटिन्यूटी का यही फॉर्मूला है, ये हम ओरिजिनल इलेक्ट्रोडायनेमिक्स में इस रो के बदले साइड, इसके बदले दिस है. सो वी कैन टेक जो रो है, इट्स n times psi star ddt of 5 by h psi, and current density जो है तो यहाँ ही इसने कहा कि डिराक ने कहा कि what डिराक realized that so relativistic Schrodinger equation can relativistic Schrodinger equation can give negative probabilities because psi is a Schrodinger equation, है ना? यहाँ पर ये 0 by dt इसके बदले ये है ना साई स्क्वायर, ये प्लस माइनस आएगा, यहाँ पर आएगा कि नहीं, है ना? सो यू कैन सी इट फ्रॉम दिस, है ना? साई की वैल्यू राइट हैंड साइड में, इसको आप राइट हैंड साइड में करो, इट विल प्लस एज वेल एज, सो इट मीन्स जो प्रोबेबिलिटी इसकी है इट कैन बी पॉजिटिव एज वेल एज, सो फॉर हिम दिस नेगेटिव प्रोबेबिलिटीज इट मे नॉट बी फिजिकली मीनिंग एज a quantity. So what he said, the problem was that that time derivatives will replace time derivatives of like Schrodinger equation. Such that हम इक्वेशन का फॉर्म ऐसे लेंगे, iota h d psi by dt will be h psi. Okay, so there are different numbers it's come out. अब यही नहीं करेंगे. So if you remember in your course in relation आपने डिराक इक्वेशन का थोड़ा पढ़ा है, have you studied it? So we will study it in detail, but the Hamiltonian of the Dirac equation का form ऐसे आ रहा है. Yes, where this H है, H is some matrix. H is some. So to have a Lorentz invariant theory, Lorentz invariant क्यों? Lorentz invariant इसलिए कि we are incorporating special relativity into it. It's relativistic quantum mechanics. When we have special relativity, it means it's Lorentz invariant. So it will have the upper bound is velocity of light. उसके नीचे ही the particles will be, ठीक है? That it's Lorentz invariant. So we can say the equation should be is linear. So idea आपको समझ आया? So what Dirac's idea was fundamentally that to do away with negative probabilities, जो original equations का form है, it is second order. So we're going to take it to first order, linear. That will solve for us the problems. अब उसका procedure ये है, if you take the form like this is evolution of wave function. है ना लीनियर इक्वेशन है ना d साइड बाई dt नॉट d2 साइड बाई dt स्क्वायर उसका फॉर्म ये आएगा h इज द सम मैट्रिक्स ऐसा फॉर्म आ गया एंड साइड दैट जो h है h कैन बी रिटन एज अल्फा 4 mc स्क्वायर वेयर ये अल्फा है ना अल्फा it may be alpha 1 alpha 2 alpha 3 alpha 4 they are constant matrices so we can derive the second order equation जो हमारे पास है it will have this form it can have this form it will have this form अभी कैसे आए यहाँ से यहाँ ठीक है so we should how it comes from this to this so h square is so you can write simultaneously so you this equation second order में इसका form ये है अब how it can be इसके बराबर है there is a peculiarity of how we define these alpha 1s alpha 2 alpha 3 alpha 4 they are matrices of the form of the way we write polyspin matrices है ना उसकी एक higher form है and they are satisfying some algebra जिसको हम कहते हैं Clifford algebra क्या कहते हैं which you might have done in your mathematical physics course तो उसमें Clifford algebra है so where basically ये linear equation है ये second order equation है so जो इसका properties of this is alpha I alpha j plus alpha j alpha I is twice delta ij alpha I alpha 4 plus alpha 4 alpha I is 0 and alpha I square is 1 where alpha is alpha 2 is alpha 1 this is alpha 2
yes
okay you write it this is alpha 3 this is alpha 4 okay so आप देखो यहाँ पर you can see this is alpha 1 alpha 2 alpha 3 and they are satisfying these properties you have to see whether they satisfy it so you simply multiply it it's a matter of proving it it will take you one page of rough or here also you can do it so satisfying these properties where alpha 4 square so you can see if you substitute here these properties of this here the equation will take the form of जो हम कह रहे हैं the equation will take this form so even though it's a second order equation but if we suitably choose these matrices alpha I alpha 1 alpha 2 alpha 3 and alpha 4 having these Clifford properties so this second order equation can take the form of देखो यहाँ पर है ना ये alpha 4 square ये 1 आएगा this term will survive alpha 1 alpha 4 into alpha 4 alpha this will come out to be 0 so it will come the equation will survive like this the equation will survive like this. Where gamma is non-stop after alpha 4 alpha, gamma is. And here you can also say gamma mu plus gamma mu, gamma mu. You can have these are properties. यहाँ तक ठीक है. So you can see if we have suitable choice of matrices को हम पहले ऐसे define करेंगे alpha 1, alpha 2, alpha 3, alpha 4. And even though this second order differential equation का particular choice of these Clifford properties को अगर हम इसको ऐसे करेंगे, it will reduce to sort of this equation. It's also in first order derivative, है ना? It's not in second order derivative. तो जो हमारे original थी ना ये d2 psi by dt square. So we can write it like this in some suitable conditions that satisfying this Clifford algebra. What my point? So this is how Dirac tinkered with it. इसका जो idea है. So do away with negative probabilities. Now we are coming to something physical. Physical क्या है? हमारे पास electron है. We are saying that we are not accounting for the spin magnetic moment जो है, जिसकी वजह से हमारे पास वो spectral lines में we could not account the exact measurement there in the original formula. ठीक है? So now what we are going to see, so iota H, so again we can write it like this. Further you can make some replacements. So if you make these replacements, iota H d by dt of plus this iota H d by dt of this, we have made a replacement in terms of potential phi into psi can be written as plus mc square alpha 4 psi. So if you make these replacements here, so we can write this equation of this form. इसको मैंने यहाँ इस साइड में ये अपना है तो इसकी बदल दी. So once we do it, for if you might have studied in your books classical mechanics, कोई भी conservative field, conservation of angular momentum का form कैसे in terms of bracket कैसे लिखते हैं, है ना? bracket form में लिखते हैं ना angular momentum. You can say Hamiltonian is iota r cross del plus x sigma by 2. You can write it like this. Where x is the matrix differential operator and जो sigma है हमारे पास, it's 4 cos 4 version of spin matrices जो हमारे पास ये हैं, where these sigma can be these different poly matrices का 4 cross 4 matrices like this. अब ये है कि the final point what we have so what Dirac did was basically he iterated समझते हैं Dirac equation 23 कौन सी है? हाँ so matrix differential operator and this इसको iterate करते he got this equation came out to the same equation as if we are solving one second, we are solving clean board साइड सिर्फ फर्क इतना है इसमें जो हमारे पास राइट हैंड साइड में टर्म्स आ गई सिग्मा डॉट बी, दे केम आउट टू बी सम एक्स्ट्रा टर्म्स. So we are going to do it in detail. So here I am trying to say how to do away with negative probabilities So he had to just take second order differential equation into first order differential equation, which he did by using this choice of Clifford algebra. ठीक है? And later इसका जो angular momentum operator लेते हैं, इसको iterate करके हमारे पास extra terms आए. And these extra terms exactly matched with the जो हमारे पास डेटा में आता था spin of the electron. ठीक है? So जो electrons Dirac's theory of electron spin. So he could have a theory of spin from first principles. जो भी है, कहते हैं. So it was in agreement with the fine structure splitting. In agreement with जो आपकी second order term थी ना वहाँ पर, if you remember, first equation पहली थी alpha square, second term थी alpha 4 mc square, denominator में कुछ था, and later इसी equation को in some refined form Davison and Gordon ने लिखी थी, the equation further refine this J plus 1 by 2. You can see in books. And mc square psi is equal to 0. So you can see this is Dirac equation and how later इसका refined Dirac version का ही refined version है, इसको कहते हैं Gordon equation, Davison-Gordon equation. So this was a brief how conceptually Dirac arrived at relativistic wave equations from a theory of spin. Even though before also we had Schrodinger's equations, Schrodinger's relativistic wave equation also. Okay, but it was in second order differentials. So it did not account for the extra order. People then theoretically speculated कि ये शायद ये इस वजह है सो होता है कि हमारे पास magnetic moment है जो spin है, we are not accounting for that. But that was qualitative. Qualitative means भौतिक, मतलब ये इस वजह से है क्योंकि we are not accounting that parameter. But Dirac accounted that parameter in some mathematical way from using this procedure. And at the end, around some two terms more, this and this. And this first term could was spin and this one. When इसका जब हम value लेते हैं at C alpha जो भी है E का, we could account for this. So this was a rough sketch about Dirac equation. ठीक है? So because it's going to, we are going to continue it later. Stop.